Namaste and welcome in the second session of Problems on the Inverse Z Transform. In this session, we will discuss how to find inverse Z transform by using power series expansion. For that, let's consider the first example in which x of z is equal to z upon 2z minus 1 into z minus 1 along with the ROC such that magnitude of z should be less than 1 by 2. Now over here, let's expand this brackets and therefore we can have x of z as in z upon 2 times z square minus 3z plus 1. Now here as the ROC is expressed such that the magnitude of z should be less than 1 by 2. It means the ROC is the inside the circle whose radius will be equal to 1 by 2. So that is representing the left-sided sequence. So therefore, to get left-sided sequence, we must perform this division such that we will obtain the series in the power of z. So therefore, let's consider a division for obtaining a series in the power of z, that means the positive power of the z. We have rearranged our denominator in such that it will be in the form of increasing power of the z. So here as the first we have to perform a division with a z, therefore we have to multiply this divisor with a z, and therefore by multiplying z with this equation we will get the first term as in z, because z into 1 is equal to z, then z into minus 3z will be equal to minus 3z square, and then z into 2z square will be equal to 2z cube. Okay, so now the next step we will perform the subtraction, and the result of subtraction will be 3z square minus 2 times z cube. Now here as the first term is 3z square, we will now multiply our denominator with 3z square. So upon multiplying with 3z square, we will have the equation as in 3z square minus 9z cube plus 6 into z raised to 4. Now we will perform the subtraction between these two equations, and therefore as a result we will have the equation which will be equal to 7 into z cube minus 6 into z raised to 4. Now as here the first term is equal to 7 into z cube, therefore we will multiply our divisor with 7 into z cube. So now we will multiply 7 into z cube with our divisor to get the next term with which we will perform the subtraction. So upon multiplying 7 into z cube with 1 minus 3z plus 2z square, we will get z into 7 into z cube minus 21 into z raised to 4 plus 14 into z raised to 5. Now we will perform subtraction between these two equations, and as a result we will get the equation which will be equal to 15 into z raised to 4 minus 14 into z raised to 5. Now over here, in this way we can perform the further division so as to get Rx of z, which will be a series in the power of z, as you can see in the equation number 1.3. This is nothing but our coefficient which we have obtained by performing the long division. Now we also know that the x of z by the definition of Z transform can be expressed as the summation of the terms x of n into z raised to minus n. So upon comparing our equation number 1.3 and 1.4, we will clearly get the sequence x of n. So for that, what we will simply just compare the terms with the respective power of the z. So here, for example, let's compare the term in which the power of z is equal to 1. So in the equation number 1.3, we will see the coefficient of the z is equal to 1, whereas in the equation 1.4, you can see the coefficient of z is represented as an x of minus 1. So clearly we can say the value of x of minus 1 is going to be 1 from equation 1.3 and 1.4. Similarly, if we compare the next term, that is the having the power of z is equal to 2 with the term in the equation number 1.4, we will get the value for x of minus 2, which is 3 in this case. So in this way we can obtain the remaining sequences for our x of n. So this is what is will be our expected x of n sequence if we compare the each coefficient of the respective z powers from the equation 1.3 and 1.4. Similarly, in the next example, we are having x of z as in z upon 2z minus 1 into z minus 1 with the ROC such that the magnitude of z should be greater than 1. So now over here, we from the ROC, we can say that the region of convergence lies outside the circle whose radius is equal to 1. That means the expected x of n will be the right-sided sequence. And to obtain that, we must perform this division in such that we should obtain a series in the power of z inverse. That means we should the division after division we should express our x of z as in negative power of the z. So for that, let's perform the division over here. As the first as here the term is equal to z, therefore we will multiply our divisor with 1 by 2 z inverse. So upon multiplying our divisor with this 1 by 2 into z inverse, we will get the equation as in z minus 3 by 2 plus 1 by 2 z inverse. Now we will perform the subtraction as a next step, and the result of the subtraction will be 3 by 2 minus 1 by 2 z inverse. Now over here, as the first term is 3 by 2, therefore we will now multiply our divisor with the term 3 by 4 into z raised to minus 2. So upon multiplying 3 by 4 into z raised to minus 2 with 2 into z raised to 2, we will get 3 by 2. Then the next term will be obtained by multiplying minus 3z with 3 by 4 z minus 2. That will be nothing but minus of 9 by 4 into z raised to minus 2. And similarly, the last term will be obtained simply by multiplying 3 by 4 z minus 2 with the 1. And that is we are getting as in 3 by 4 into z raised to minus 2. So next we will perform the subtraction between these two equations, and here as a result we will get a equation will be equal to 7 by 4 into z raised to minus 1 minus 3 by 4 into z raised to minus 2. In this way we can perform the further division so as to obtain our x of z as a series in the power of z inverse, and therefore we can write x of, after the performing long division, we can write x of z is equal to 1 by 2 z inverse plus 3 by 4 z raised to minus 2 plus 7 by 8 into z raised to minus 3 plus 15 by 16 into z raised to minus 4, and so on. But we also know that x of z can be expressed as in summation of x of n into z raised to minus n by using the definition of Z transform. And therefore, by comparing the coefficient of the respective Z powers, we will get the values for respective x of n sequences, which will be here are right-sided sequences as expected. Thank you.